In homework 1.2, you're asked to, for each type of function, create an example function. It also asks you to make a table by choosing x values for it, and making sure you choose x values that show the shape, finding the corresponding y values, and then we're going to graph it. So, the first thing I'm going to do is I'm going to choose an equation. I'm going to do the quadratic one for you. The other ones are very similar. My equation is going to be f of x equals x squared minus 6. I'm going to make a table for it. I get to choose the x values. Now, I know that this is going to look like the parent function shifted down by 6. And so I know I want some negative and some positive x values. So I'm going to make mine -3, -2, -1, 0, 1, 2, 3. When x is -3, I want to find the y value, and this function rule tells me what the y value is. It says the function will be x squared minus 6. Since x is -3, it's going to be -3 squared minus 6. -3 squared means -3 times -3. -3 times -3 is positive 9. 9 minus 6 is 3. So when x is -3, y is positive 3. That's a point I'm going to put on my graph. When x is -2, -2 squared is positive 4. 4 minus 6 is -2. So when x is -2, y is -2. When x is -1, -1 squared, -1 times -1 is positive 1. 1 minus 6 is -5. So when x is -1, y is -5. When x is 0, 0 times 0 is 0, minus 6 is -6. When x is 1, 1 times 1 is 1, 1 minus 6 is -5. So when x is 1, y is -5. When x is 2, 2 times 2 is 4, 4 minus 6 is -2. So when x is 2, y is -2. When x is 3, 3 times 3 is 9, 9 minus 6 is 3. And so I get a very beautiful parabola here. I'm going to make sure to connect the lines because there are values in between even though I didn't choose them. I'm going to put arrows on the ends of my lines, and that's that problem. In the second section, you are asked to find the range given the domain. And in this case, we're looking for the range. I'm going to choose the first problem, and the range of it is going to be whatever all the output values are. So we have a domain of -3, 0, 1, half, and 4. These are all the possible input values, all the possible x values. So each one of these is a possible x value. I need to find the range, which is all the possible output values, and there'll be an output value for each input value. So what I'm going to do is I'm going to first start by finding f of -3. I'm evaluating this by plugging in -3 into the function. And we have to do PEMDAS here. We have to do what's inside of this grouping symbol. -3 minus 1 is -4. The absolute value of -4 is positive 4. And from here, I'm just going to do all the steps. 2 times 4 is 8. 8 plus 1 is 9. And so f of -3 is 9. That's one of the answers. I also need to find f of 0. F of 0 is what I get when I put in 0 for x. So it's 2 times 0 minus 1 plus 1. I'm going to do all these steps at once. 0 minus 1 is -1. The absolute value of -1 is positive 1. 2 times 1 is 2. 2 plus 1 is 3. So f of 0 equals 3. I also need to plug in 1/2. When I plug in 1/2, I'm going to get f of 1/2 equals 2. And I need to plug in 4. F of 4, when I put in 4 for x, I will get 7. So the range values, I have not answered the question yet. The range is all the possible output values for this given set of input values. The range I need to write, and I'm going to label it right here. The range is a discrete range, and so I'm going to use braces, just like it was in the domain. And I order them from smallest to biggest. So 2 is the smallest output value, then 3, then 7, and then 9. Close the braces at the end. This is my final answer. Okay. Let's see. I'm going to do one of these guys. Let's just do the first one here. I'm supposed to be identifying what type of function is in each table, and I want to try to see if I can find the exact function rule. The first thing I might look for is, does it have a constant rate of change or a constant second difference? And I notice it goes up by a fraction, goes up by 2/3, and then by whole numbers. So that doesn't seem like it'll be a constant difference or a constant second difference. So the next thing I'm going to do is see if there's a constant multiplier. I'm going to stay away from the fraction for just a second and look at this. Is there a constant multiplier going from 1 to 3? Well, you multiply 1 times 3 to get to 3. You multiply 3 times 3 to get to 9. And so the question is, can you multiply 1/3 times 3 to get to 1? And the answer is yes. There is a constant multiplier of 3. Since there's a constant multiplier of 3, that tells me it's exponential. And hopefully you can recognize what function this is. This is the parent function, y equals 3 to the x power. We can tell this pretty easily because 3 to the 0 power is 1, 3 to the 1 power is 3, 3 squared is 9, and so it matches exactly. On the back, you're supposed to be starting to learn how to study for a mastery quiz. So from your mastery quiz, you need to take 3 of the problems that you got wrong on your mastery quiz, try 1, and for each one of them, so problem number 1, maybe you missed how to solve the first question. Oh man, I don't even have it in front of me. But maybe you missed the first question, which was something like 35/9 equals, I think it was 5/3 x. You need to make sure you know how to do it, so get some help on it, or maybe look at the videos from the summer homework, and then you need to make up 3 that are like it. So if it were me, I would make up a problem something like this. 2/3 x equals 5/2. 2 might be 2x equals -3/4. 3 would be 5/4 y equals 2/3, and I would try to solve each one of these. That's problem type number 1. Then I would need to choose another problem that I struggled with on the mastery quiz, perhaps a problem like simplify 2m squared times m to the -4th n to the -4th. I need to make up 3 more problems like that and try to solve them. And I'll do that for one more type of problem, and by the time I've gotten some help on this and then practiced it a few times, I should do better on my next mastery quiz. I hope that helps.